So good morning, everybody. Thank you for joining us again this morning. To review about the edge, where we were, we've seen a lot of conversations, we've seen a lot of discussions these past few days. We wanted to just bring it back a little bit to some of the real world requirements, concerns, issues that our customers, that our joint customers, that as end users we are facing. Bret Lehman from IBM will be doing a case study reviewing a smart government application. So you know about the edge, you know why it is important. The edge today is where the cloud was 5 years ago. We've always been on the cloud, but then when somebody said it's the cloud, whoa, I gotta be on it. So that's cloud. Where did it live? It lived someplace. We are just moving it further and further away. So cloud has become the new edge. And now that we have a new buzzword, we have to be there. So we will have the cloud, we're on it, and the cloud then is going to be at the edge, keeping the data close. We're going to define a slightly different edge this morning than what has been discussed over the past couple of days, as well as some new ideas for what's going on. We know about the connectivity. We know about everything being connected. We'll talk here in a few moments about smart everything, our sensors. But most important is, everything is linked. So we now see that all of our sensors, all of our applications are moving again further out of that data center, moving further away. We need the real-time analysis to see what's going on. We need the real-time availability to act upon that. We don't have to now go back to our core data centers. So that's what's happening. We're putting all of these different things all over the place. But doing that, we're still driven by the same concerns that we have at the data center level. We have our volume of content, the nature, what it is, that's very important. Of course, latency for us is critical, and of course, location, where we are, where we need to be, how fast we need to get there. You put up the charts, you search online, you will get what is happening on it, how many videos, how many Snapchats, how many emails, how many this, how many of that. So we know that this number continues to grow, but we must think outside of the traditional application world, because this is internet, this is IoT. Part of the thing that's driving edge for us is IIoT, the industrial Internet of Things. And that will include smart cars, smart grids, smart metering, smart transportation systems, and so on. All of those also fall into this. We don't even show that what is happening in that Internet minute. We're showing LinkedIn and Snapchats and Netflix. We're not showing how many cars were built or how many little Chobani flip yogurts were made in Australia. Right? That's all edge. That also is now contributing to the volume and the growth of the traffic, which is over here at the far right. The sensors, the number of sensors, over 200 billion. This is not IP. This is not TCP/IP or SNMP Ethernet protocol. This is I/O. Input, output, ones and zeros, bits and bytes, making things from cars to yogurt to, whatever we build out there today, and controlling our traffic lights, and controlling our subway systems, and controlling cruise ships, and controlling autonomous vehicles. Can't say smart cars anymore. They are autonomous vehicles. Okay? Those sensors are what are going to drive us further out to the edge, out of our traditional data center. We will explain that in just a few moments to give us both sides of the edge argument. Of course, we still have our apps, our users, our devices, and so on. But a device, if we do the math, could one device support 4 sensors? No, it'll support hundreds and hundreds of sensors, going back to that device. Latency, critical. We know about speed. Now, we've always talked about latency when we were in the cloud, right? The cloud was all about latency. I can do that trade that much quicker. We were shaving nanoseconds off of our time from point A to point B. A great book, side note, a great book, Flash Boys, tells about when they were first looking at data centers to support financial trading activities, the high frequency, low latency algorithmic traders, they were looking for the fastest pathways from New York to New Jersey to Chicago to San Francisco to Tokyo, back to Frankfurt. May not have been over fiber, may have been over microwave. So they're very interesting about latency and about how they sold it. Does everything need the highest latency? No. Driving a car? Yeah. Checking your emails? No. So you will decide as you move further out of that core data center to the edge how important the latency is and how much of it you need to support your bandwidth. Of course, we're going to hear 5G, right? The next new buzzword we'll be talking about next year here. Steve Warren, I'm sure, will set us up for the 5G conference. Okay? And finally, we, of course, always talk about location, 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 location. We are moving out of our core data center locations here in the New York metropolitan area and northern New Jersey, northern Virginia, Chicago, Dallas. We know those core markets, Silicon Valley and so on. Then we go to the tier 2 cities, you know, the NFL cities, right? Minneapolis and Green Bay and those places. But then we go even further afield. Those are still going to be a data center, but we give that mesh network as we put here. So now my edge stays local. It looks at what I need to look at locally. It acts on what I need to act on locally. And then whatever I need to push forward out or push back out to our core data centers, even if they are an edge data center, we can do that as well. And location now will be everywhere. It will be at traffic signals. It will be in subway stations. It will be in airports. It will be on cruise ships. As we move further to the edge, of course, the challenges that we have always faced are there. To me, the most important challenge, not the speed, not the network, and so on, it is the security, as we just saw previously. And we've talked over these past days. Security is critical. So, a very quick show of hands. How many of you have a USB stick on you right now? Okay? How many of you have a weapon on you right now? Keep your hands up. That is a weapon. That is a weapon. I can take it, I can put a virus on, I could surreptitiously, because Henry and I have done this, we sneak into places. Did I say that out loud? I'm sorry. That is a weapon. I can do things with it. I mean, so we all cover up, and I don't want to show of hands, you know, our little cameras on our laptops because we are worried about our privacy. But yet how many times do we go and we put a USB stick into somebody else's laptop? No offense. I don't know where your laptop has been. I don't know what you do on that laptop. All right? Certainly in today's age of security, of privacy, of hacking, when we hear about things, you know, the hundreds of millions have stolen here and taken there and, you know, and hacked here and sold there, the dark web and all of that. Now, as we get to the edge, we also have to add a layer of physical security as well. And that is keeping me out of your cabinet in the middle of a field underneath a cell tower in Nebraska as I'm driving, you know, cross country on Route 66. So I think all of the application challenges we can answer. That security, that privacy, to me, that is what we have to consider because now we won't have the luxury of being in a nice, safe, secure building. Also, as we move further to the edge, what are we doing there? What is driving us there? Are we moving away from the cloud? We are, because we're going to keep it at the edge, we will still be a node on that cloud, but do I need the whole cloud? I mean, there's a whole cloud there, or can I move it someplace else? We look at data centers, we look at consolidation, but I would also look at moving, again, as I keep saying, further and further out. So expansion of our network as we learn to do more smart things with more smart sensors. So all of the factors, still the same thing that drive us, but now again, without the luxury of having the security. Because I will be in a subway station. I will be on a cruise ship. I will be underneath a cell tower in a field and wherever. I'll be along railroad right-of-way here in the Northeast and across the country. Positive train control, right, to prevent the crashes that we've seen certainly here in the Northeast and elsewhere. Right? That's a cabinet someplace sitting. Hey, I might get nosy and see what's in there. And I'm going to have my little USB stick, and I'm going to pop it in. I am not worried of going to a massive co-location site and having somebody go through 5 or 6 or 7 layers of security, physical, biometric, escort, and so on, and in a 10,000 cabinet data center find my cabinet. I'm not worried about that. I'm worried about him sitting in the parking lot, just hacking away. So the security, we have to make sure, excuse me, that you have a solid security plan, and that everybody is on board with that, from the top level to the very, very bottom level, and everybody in between, because you are in business. You do things. And the last thing that you want to have happen is me standing up here in front of a room full of people reading today's Wall Street Journal or USA Today or New York Times and saying, so-and-so got hacked and lost 150 million usernames. You know, you might as well just go home if I do that. I didn't do it today because I didn't have time to look at the paper. So, should have. So understand what we are doing. Okay. So we know we got to go to the edge. We want to look at moving from the cloud through the edge locally, have that aggregation of I and IoT, both the Internet of Things and we know it, as we know it, and the industrial Internet of Things, making all the things that support IoT and that we can then do things with. Eat the yogurt, drive the car, fly a plane, ride a train, do whatever we need to do. Bandwidth is still important, of course. We know that we live in that. We know 4G is gone. We know 5G is coming. We know IPv6 is out there. I heard some ridiculous number. I don't even know what the preface was before the million thing about how many gazillions of IP addresses V6 will provide as opposed to V4. It was, Henry, do you know that number? Like some really weird number. I think the guy made it up. And knowing that we can still use our existing data center infrastructure, our hyperscale sites, our co-location and enterprise class sites, even our on-premises sites if it is a large enough facility. But then as I said at the introduction, all of the smart stuff that we have today supporting really what we expect, smart everything. How many of you people have a dumb phone in your back pocket? I know Dr. Bob does, but I think he still has a razor. No, I shouldn't say that about Dr. Bob. We have smartphones. How many of you have a dumb car? All right, it may not self-drive, but we hear the analogies that I drive a Ford Edge. I speak about the Edge. That my car has more processing power than NASA had to put a man on the moon. All right? So we are used to having smart. That is what we need to support. That is what edge for us will support. Oops, I'm sorry. And for my edge, you will still have your edge data center, but if I call it an edge data center, the operative word there is data center, not edge. It's still a data center with all of the luxuries that we expect from our facility. Bret will address some of those luxuries that we do not have. This is the edge that we are going out to. Small, independent, dedicated installations. These are not rules. There's no code. There's no Bixby or IEEE or ASHRAE guidelines for this. This is a general recommendation for what I think the edge is. Number of footprints. I think we go in cabinets. We may not have the luxury of backup power, redundancy, resiliency may not be there or may not be required. And if it is, we can adjust it. If you have 11 cabinets, is it an edge? Yeah. Again, it's not a hard and fast number, but climate control, all of the things we see in our data center locally that I can access remotely, of course, critical. And the most important bullet is the one on the bottom. I am still going to that cloud. I am still going to go back someplace where I will look at that data, I will archive that data, I may act on that data in some future, but I want to keep everything locally. So we still are that mesh network. We still maintain that level of connectivity, but now we have the selective capabilities to see what I want to keep locally, what I want to act on locally, and what I want to send remotely. So this is a little bit of a different edge than what we've been talking about over the past 2 days. Remote, probably lights out, probably nobody running around there, and if it does break and you got to get somebody out to a field in Iowa or along a railroad track in Nebraska, whatever, let alone in New Jersey or New York, it's not that easy. So we talk about the solutions. We'll talk briefly about some of the things that we are going to look at, and please visit the Rittal stand upstairs to see some of these solutions. Non-traditional IT, Bret is going to talk a lot about that here in just a moment. Again, all of the things you would want. We talk about costs. There's not a PUE conversation here. There's not a TCO or an ROI conversation. Can it be had? Absolutely. But that may not be the driving forces behind this. Okay? So we want to make sure that we have a knowledge that we can get you out into further places. Scalability, modularity, all of the systems that you want that we have always talked about in our data center, flexibility and so on. The edge solution, wherever it may be, must provide that as well. Number of different variations. Number of different things that work, how we want to scale it. Now, if we stop at 8, do I go to 10? Do I go to 20? Sure. Is it edge? Maybe. It may be in a non-traditional space. It may go up to 20 or 30 footprints, but I can scale. And you want to be able to have that scalability. You want to be able to have those capabilities. Bret will discuss how we actually implemented them. So let me bring up Bret Lehman from IBM. He will give us a couple of case studies that we've had recent experience with.
So I think it's always helpful in a conversation like this to try and make it real. I think we all probably come here with a preconceived notion of what the edge is and what an edge solution looks like. So I'm going to describe, as Herb said, a couple of case studies that may not be what your impression of the edge is, but the reality is there are applications out there like this. So this particular client is a public sector client here on the East Coast. They are deploying new technologies, and their end users are in the hundreds. There are hundreds of these end users, and they operate out of dozens and dozens of offices. So the volume, first of all, in what we had to try and handle was a little bit daunting in and of itself. The other thing that was really important about it was, from the client's point of view, is the information that's being gathered is really sensitive. And they've always done this manually in the past, or they've done it across, CD, media, that kind of stuff. This is the first time they're going to be transmitting really sensitive data over their network. So those were the important things to the customer. A little bit about some of the challenges we faced. I mean, I think those, in this big room, those pictures may be a little bit hard to see, but they speak volumes about what was available to us to put the solution in. So it wasn't, there wasn't an overwhelming amount of space. The space that was available was not your typical what you would expect, a data center to look like. They're wiring closets, and they're in a lot of cases in 100-year-old buildings. So getting from point A to point B with connectivity was definitely not trivial. In a lot of cases, you can tell from some of that cabling, that there wasn't. I think what the one customer told me was, in this kind of an environment, nobody wants to pay for maintenance. So this was an opportunity to take multiple network, IDFs, and converge them into, or collapse them into a smaller number. So there was some of that going on. The network was live, so we needed to have a solution that we could cut over without disrupting what was currently going on. So if you kind of look at these closely, you'll see that these are before and afters. So the 2 rooms before and the 2 rooms after. So that gives you a little bit of a sense of some of the structure and discipline that was required to make this thing work. One of the real challenges was, in addition to the age of the buildings and trying to make things work from that standpoint, was that there are hundreds of these locations, a couple hundred of these locations. And the scope of the project is going to happen over about an 18-month period. So if you do the math, on average, that could be as many as 3 to 4 sites a week. So each site has to be surveyed, and I'll get into how we addressed each individual site. But the site's got to be surveyed, a design has got to be done, there's an implementation plan, and then you cut over live. That could happen over the span of 14 to 28 days, 2 to 4 weeks. So it's constantly rolling. This is constantly rolling animal for about 18 months. So a little bit about the solutions, and Herb touched on this, is because of the nature of the spaces, we took some solutions that were really, I think, envisioned for the industrial space, and we adapted them. That's a really important word. We adapted them to what was available to us. You dance with who brought you, right? So we had to make do with that. These solutions you can see down in the booth later on today if you're interested, but we have examples of what we did there. For cooling, if we had ventilation available in the room, a lot of times all we needed was, if we had space for a cabinet, we put a fan and filtration unit on it. And that was adequate for the amount of load that was in the cabinet. A lot of these spaces were non-conditioned, so you see the self-contained DX fully enclosed. We added some backup power and some things like that. But one of the most important features was, I mentioned earlier, that these cutovers had to be done live. We couldn't disrupt what was going on. So the cabinet selection was huge in the sense that we could take a wired switch and twist it and contort it down into the cabinet and mount it without disrupting what was already there. So all those features, you think of maybe an edge solution as 2 or 3 cabinets, nice and clean. You put it in every Home Depot or every Target store. We didn't have that kind of luxury here, so we had to adapt to what we were doing. The ideal thing would have been to do a number of surveys and come up with a number of standard solutions. In reality, every single one of these has been different. So we do the next best thing. We use standardized components. So we've got a lot of stuff to choose from. It's all standard components. And sometimes that's the best you can do is standardize as much as possible. Our designers have a clipboard of all the different solutions they've used, and the clipboard's getting bigger. They just plug whatever they need into the solution from the clipboard. So that's the East Coast case study. This case study is less about edge, but I think it's important because a lot of the requirements and the design attributes apply at the edge. It's a cryptocurrency mining application. I think the previous speaker was talking about some of that stuff. On this one, there were some other things that were important, but before we were even done with the design for a 20-cabinet solution, you'll see there's a row of green cabinets there, the requirement changed. These cryptocurrency miners a lot of them are startups, they're volatile. We had the fortunate case where ours saw growth immediately. And with that growth, they also want some investment protection. They want to know that if I outgrow, I've already outgrown my business partner's garage, so we're now in a storage space, a non-traditional space. We want the investment protection to know that if we need to, we can move this somewhere else and take advantage of scale. So this is a fully self-contained solution, airflow, fire suppression, and it allows us to not have to worry about building the room, build the fire suppression for the room. If these guys decide to move this, they can disassemble it and reassemble it in another location pretty quickly. So pretty high density, maybe not for a lot of the cryptos, but about 15 kW per cabinet, so it's all close coupled cooling. They really highly valued efficiency. I would have thought, as the kind of business that gets paid by transaction, they'd be really looking at redundancy, which we provided in the cooling, but they were really interested in efficiency. So the close coupled cooling allows us to fully enclose it and do that efficiently, and at the same time, we did some power upgrades and added a chiller that they wanted an economizer on. So they were really conscious of those kinds of things as well. Everybody's different. Some of the cryptos, they say they want Home Depot shelves, and they're putting these custom-built servers on the shelves, and they're opening the front and the back of a container, and they're just blowing air through there. And so this customer had a little bit more robust requirements than that, but they're all over the place, a lot of them. I'm not going to go into this a whole lot, just some other examples of edge solutions or solutions that have the same kinds of attributes as edge. I think in my last statement, I would say the edge is part of an evolution that we've seen happening for the last 12 to 15 years. Back in 2006, we at IBM started talking about green data centers, and we solved those issues by scalable, modular, adaptable solutions, energy efficient. And that resonated. So that morphed into when the economy kind of took a downturn in 2008, 2009. What do you do in a tough business environment? You optimize your operating costs, you minimize your capital costs. It's the same set of solutions, right into cloud enablement and now edge. It feels like edge is the next turn of the crank of what we've been doing with modular solutions over the last decade plus. So I'll leave you with that thought and turn you back over to Herb.
Case study. Important to understand that as we go further out, and again, I want to stress, those are the conditions that we face. Those are the conditions you will face. Is an edge solution right for every application, every condition, every installation location? Perhaps, perhaps not. But as Bret stressed, modularity, scalability, whether we start with 1, grow to 5, move to 10, go to 20, go to 30, then you know what? I'll pack it up and I will put it in an edge data center. I'm still at that edge, that's fine. I'm now in a data center, but now that then becomes my enterprise data center, which is going to let you guys go further out to the edge. Finally, a brief word from our sponsors, Rittal and IBM. We thank you for your time this morning. If this looks familiar, years and years and years ago, there's like 2 people in the room, myself and Henry, who are old enough to remember the 7-layer model. I never knew what the 7 layers were. I was quizzed once and I failed horribly. A variation on the theme today, building blocks, foundations, but again, scaling of the integration levels, moving you up the stack, but having a solid foundation to build on. All of the things that you still need, the power, the cooling, the security, the access control, the monitoring, whether it's an individual footprint. We hear data center in a box. We hear modular data centers. I caution using those terms because we're not quite sure what they mean. A modular data center could be 1 or 2 standalone footprints, but there are data center providers, the big managed service providers that say they have a modular data center because they build it out in 50,000 square foot increments. They have the spine and they just drop another module. It's a 50,000 square foot module, not a 50 square foot module. So while we try and use the same terminology, we have to make sure that we understand what we are asking for based upon where it is going. And then from the full range, from the hyperscale data center through the edge solution, please give Bret or myself a call. We thank you for your time this morning. We hope you enjoyed the event. We look forward to seeing you up on the show floor. And again, thank you for coming this morning.